Ooh, apologies for that. Technical difficulties. Not sure what happened there. Hello, hello. Okay. Hello world. So I'll be going through a few questions, but if you have any questions that you need help with, let me know, and we can go through them. So I thought, yeah, you can send me maths questions, please. Please send me maths questions. I love them. I am encouraging you and maybe helping you to get some homework done. That's the idea, I guess. You know, if you're finding it hard to get motivated to get some maths homework done, then this is the homework hour. That's what it's for. But I thought I could go through some questions from the November GCSEs that just happened. This is the first paper, the non-calculator paper. Boat. Hi Nathan, TJ. Hello. Hello Boat. I'm on A-level mathematics now. Just wanted to say thank you for getting me from a 5 to an 8. That's awesome. Thank you. Well done, by the way. Well done on the 8. That's awesome. Hello world. Yes, you can send me A-level questions. I can't guarantee, like, if they're super hard that I'll be able to get them, but I could try and we could see. Hello Abdi. Alright, so I'm going to be going through a few questions from this paper. I'm not going to be going through the whole thing. I'll see how much I can get through, and while I'm going through it, if you have any questions, let me know. If you want to send me some to the email on the screen, feel free. I have that open, so if anything comes through, then I'll see it. Okay. I'm still not. Yeah, this YouTube thing is this YouTube live thing is a bit glitchy at the moment. Abdi, you want the paper? I can post a link, a drive link, so you can get the papers if you want those. I think that, let me know if that opens up the papers, it should. Okay, so question 1, I'm not going to go through every question as I said. Lowest common multiples. There's a pretty standard way of doing this, so you can break the numbers up into their prime factors. And then once you've got those prime factors, you need to know how to use those to get the lowest common factor. Alright, I'm still trying to fix certain things here. Alright, here we go. Hello Ivan, welcome. Alright. Alright, so let's see. Let's break 108 into its prime factors. So 108, 12 times tables, because 12 goes into 120, so it must go into 108. 12 times 9, and then 12 times, well, sorry, 12 is 3 times 4, and let's actually write 4 as 2 squared. And then 9 is 3 squared, so 108 as its prime factors, 2 squared multiplied by 3 cubed. Then 120, well, you know that's 12 times 10, and again, same issue, same situation with the 12. 10 is 2 times 5. So 120 we can write as 2 cubed times 3 times 5. Hello Mohammed, welcome. And now the lowest common multiple, lowest common multiple of 108 and 120. Use those prime factors. So if you imagine these in a Venn diagram, that's one way to do it. Another way is just to look at them and take the highest power. So 2 cubed is the highest power. So we take 2 cubed, and then we have a 3 cubed. That's the highest power there. 3 to the power 1 is lower than 3 cubed, so we take 3 cubed. And then we only have 1 5, so we multiply by 5. And that will give you the lowest common multiple. And then all we need to do is work out what this is, and then we have our lowest common multiple. So 2 cubed is 8, 3 cubed is 27, and all of that is multiplied by 5. From here, do it however you would like to do it. 8 times 5, 40 times 27, and then 40 times 27, you could think of maybe 800 times, 800 plus 40 times 7, 280, so 1080 for the final answer. So I thought I'd just start off with a warm-up question. Samarine, hey, hello, I'm currently in year 11 and hitting a high 7, low 8. What do I need to do to secure a guaranteed 8 or maybe even a 9? Thanks in advance. Well, a good start is to get in the habit of doing homework. I'd encourage to do work outside of school in your own time as well. And I have a video I've made in the past on revision tips and things like that, if you want to check that out. Someone's saying check my email. Okay, this is the November paper 1 of this year. Ivan came from playing Fortnite. Awesome. Get some learning in. Maybe have a break from Fortnite, do some maths, and then go back to it. Okay. Alright. Abdi, I think you forgot to attach the question. It just says... Oh, okay, so you want an overview of binomial expansion. I'm not going to do that now, but I could do that in another... I might do a stream actually on A-level, some A-level topic. Someone was asking about hypothesis testing. And the circle 6 to 9 markers. Okay. Alright, I'm going to continue with this. I'm going to continue on this paper. Okay. Alright, next question I wanted to go through was question 6. Alright, and if at any time I go past a question you think looks interesting and you would like to go through, let me know. Alright, this question. How old am I? Can I think of an equation for you to solve? No. You've just given me an idea, Ivan. I'm going to create a problem to solve, and the answer will be my age. But I'm not going to do it right now. Okay, question 6. 4 red bricks have a mean weight of 5 kilograms. 5 blue bricks have a mean weight of 9 kilograms. 1 green brick has a weight of 6 kilograms. Donna says the mean weight of the 10 bricks is less than 7 kilograms. Is Donna correct? You must show how you get your answer. Okay, so the problem here is how can we find the mean weight of the 10 bricks if we're given the mean weight of each color separately? If someone wants to have a go at that, suggest an approach here. Think about what a mean actually is. How would we come up with this mean of these 4 red bricks? It's a bit of a delay. I wonder if I can turn that delay down. Would be good. Four times 5, yeah. So the sum of the red bricks, the sum of their weights, divided by the number of bricks, which is 4, will equal 5. That will give you the mean. So then the sum of their weights, that symbol means sum, will be 5 times 4, which is 20. So regardless of what their individual weights of the bricks are, you know the sum of the weights is 20 kilograms. And then you can do the same thing for the blue bricks. So the sum of the blue bricks divided by 5 equals 9. Awesome. Then the sum of the blue bricks is 45. And we know they've told us there's only 1 green brick, and that's 6. Exactly. Awesome, guys. And then if you wanted to write out, kind of make your working out really clear, you could say the sum of all the bricks divided by the number of bricks well, the sum of the weight of all the bricks will be these weights here, 20 plus 45 plus 6, as Abdi said, I believe, divided by the number of bricks, which is 10 in total. 20 plus 45 plus 6, that's 71, divided by 10, which will be 7.1 kilograms. Exactly, she is incorrect. She said the mean weight is less than 7 kilograms. Always make sure you answer the question. So we need to say Donna is incorrect. The mean weight is 7.1 kilograms. Okay, so any questions, any comments before I move on? Okay, next one I wanted to go through was question 11. I posted this up, so I thought I might as well go through it. It's only a 2-mark question, so hopefully not too difficult. King Panda, welcome. Not a regular stream yet. This is my second live stream. So, but I'm looking to make it a regular thing. Alright, so question 11. There are P counters in a bag. 12 of the counters are yellow. Shafiq takes at random 30 counters from the bag. 5 of these 30 counters are yellow. Message retracted. That's strange. Oh, are people... Okay, that's fine. Work out an estimate for the value of P. So, the fraction of yellow counters initially, you could say, is 12 out of P counters. And then we also have another fraction to represent the yellow counters, which is the picks that Shafiq has taken. So she's got 5 out of the 30 counters are yellow. So we could say these things are equivalent. It won't be exact, that's why it says estimate for the value of P, but we can say they're equivalent because they'll represent the proportion of yellow counters out of the total. So to work out P, well, we could simplify this fraction first. 5 over 30, that's 1 over 6. And then if we cross multiply, so if we wrote this so it's really clear, if we cross multiply here, we'll have P times 1, which is P, 6 times 12, which is 72, so we would have P equal to 72. So the estimate for the number of counters in the bag, 72. Thank you for anyone that liked this live stream, appreciate it. Feel free to give it a like if you think it's useful. T-Boy, welcome. No, I'm trying to kind of keep it open to GCSE and A-levels. At the moment, I'm going through this paper here, the 5th of November GCSE paper. So I'll continue going through that. But if you have questions and they're A-level questions, feel free to send them to my email and I'll give them a go. like either now or after I get done with whatever I'm working on. And so yeah, this is what I'm doing at the moment, but I'm open to answering different types of questions. Okay, where was I? Question 11. Excuse me. Okay, next one I wanted to do was okay. No, maybe we can do that one later. How is everybody with turning recurring decimals into fractions? Does anybody struggle with that? I've actually seen this question come up, I think it was in the last 2 sets of papers, so I think that it didn't come up in 2017, I don't think, but they've put it in the last few sets of papers, so you know, a good topic to practice. Okay, Abdi, you've sent me a whole paper. Any particular question in that paper that you're interested in? Oh, you can't get that link to work. That's interesting. Hello, Blue Snow. People are saying this is easy. Okay, that's good. That's good. I like your confidence. Okay, next one. Similar three-dimensional shapes is what I thought I would go through next. Someone just said that this link's not working, so I just thought I would make sure. It should be working. I've got it. Yeah, it should be working. So the email should be on the screen, just at the bottom of the screen there. Okay, alright, this is the next question, question 17, and I might go back to those other ones, those recurring decimals questions after this, if people are interested. Okay, alright, so A and B are 2 similar cylindrical containers. The surface area of container A is the surface area of container A to the surface area of container B, the ratio of those equals 4:9. Tyler fills container A with water. She then pours all the water into container B. Tyler repeats this and stops when container B is full of water. Work out the number of times that Tyler fills container A with water. You must show all your working. Okay, so what's the trick here? What's the relationship between the surface area and the volume? Well, probably the easiest way is to relate it back to the height of the containers. So work out the ratio of the heights first, and then work out the ratio of the volumes. So the ratio of the heights, so we're talking about the heights of these containers, height of A and the height of B. So if we look at this ratio, this is going to be the square root of the ratio of the surface areas when they're similar three-dimensional objects or prisms. Tomorrow, welcome. A-level, I'll try to do an A-level one going through some A-level content, I don't know, this week, possibly, if you think that would be useful. So, the ratio of the heights is the square root of the ratio of the surface areas. So the square root of 4 and 9 would be 2 to 3. So we have the ratio of the heights. Then the ratio of the volumes is the cube of the ratio of the heights. Oh, is the music too loud? Sorry. Okay, so we need to cube these. 2 cubed is 8, 3 cubed is 27. So we have the ratio of the volumes. Another way of writing this is as a fraction, of course, so we could write it as the volume of A over the volume of B equals 8 over 27. So what does this mean? This is just a copyright-free playlist, so that's why it's not so good music. So now we have the fraction of the volumes. That means that, well, if we took well, we don't have units here, but if we took 8 units from container A, put it into container B, we would have to do that, well, at least 3 times, right, to fill up container B, and then 3 and a bit more. So what do we actually have to work out? Well, we have to do 27 divided by 8, which is going to be 3 and then 3 left over. So basically 3 and 3/8. So we filled that container A up 3 times. We'd have to fill it a 4th time as well, but we wouldn't use all of the water from container A. So I would just write an explanation here. Well, the answer is going to be we have to fill it 4 times, but we could say just a little explanation to say something like, you know, Tyler will have to fill up the container but he won't use all of the last one. Something like that. Classical music, some of that is copyrighted. That's the problem. Okay, so that was question 17. That was 3-dimensional shapes, similar 3-dimensional similar shapes, and the ratio of those. Okay. Next one, functions. I do get quite a few questions about functions. So I thought I would go through this one. As well. So question 18 says function f is given by f of x equals 2x cubed take 4. Part A says show that the inverse of f, how do we state this? The inverse of f of 50 equals 3. Okay. Well, first we would have to find the inverse of f. And there's a process you can do, you can follow to do this. So I'll follow that process. you could take a shortcut here and kind of jump straight to the inverse if you wanted, but I'll just go through that process because it's useful to have a method to tackle these types of problems. Yeah, copyright is weird. So here we can say, oops. Here we can say let f of x equal y, and then we can just say y equals 2x cubed take 4. And now what you want to do is to rearrange this so x is the subject. So add 4 to the left hand side. And then I'm going to flip it around actually. So I'll say 2x cubed equals y plus 4. And then x cubed equals y plus 4 on 2. So dividing by 2 on the right hand side. And then x would be the cubed root. If you want to get rid of that cube, you take the cube root of y plus 4 on 2. And now what you want to do, awesome Edmontosaurus, nice name, Edmontosaurus 123, well done. And then what you want to do is to let the inverse of f of x equal this and change the y to an x. So this is going to be the cube root of x plus 4 on 2. So that's how you find the inverse of a function. And then if it's saying the inverse f of 50, input 50 into this expression. So we get the inverse of f of 50 equals the cube root of 50 plus 4 on 2, which is the cube root of 54 on 2. 54 divided by 2 is 27. The cube root of 27 is 3. So 3 times 3 times 3 will give you 27. So quite a bit of work there for 2 marks. As I said before, they probably are not expecting you to do this, kind of take these steps to find the inverse. I think the marks would be mainly getting this expression here and then getting to the answer. So this is just to kind of illustrate the method that you want to use. Okay. Alright, let's continue. The functions g and h are given by g equals x plus 2 and h equals x squared. God, this music is terrible. Sorry about that. Part B says find the values of x for which h of g equals 3x squared plus x take 1. Alright. Kind of a different question. I haven't seen this type of question come up before, but it's not, crazy different. It's just a slightly different way of getting to the answer. I agree, Edmontosaurus 123. I agree. It's good to take those extra steps just to make sure you're not making any mistakes. Okay, so firstly we want to find h of g here, which is a composite function. How do you find a composite function? You input the function of g into the function of h. So the input here is x. The input becomes g. In other words, we want to take this function and input it into h. So where we have x here, we'll have x plus 2. So h of g is going to be, x plus 2 squared. Okay. So hopefully that step, yeah, this is the non-calculated paper, Emmanuel. So hopefully that step makes sense. How we're getting x plus 2 squared. It's just that x, we take that function and replace that x with that function. Okay, next, can anyone see the next step here? They're asking us to find the values of x for when h of g equals 3x squared plus x take 1. But we already have a value of h of g. So what we want to do is to say, well, when these two things are equal, we can find the value of x. So we can say that when x plus 2 squared equals 3x squared plus x take 1, that will give us the values of x that we're looking for. Okay, then we have an equation we can solve for x, and we just need to go ahead and simplify this into a quadratic that we can hopefully factorize and get two possible values of x. Excuse me, I just need a drink. Okay, so first thing I'd do here is expand out those brackets. So we'd have x squared plus 4x plus 4 on the left, and then we still have that 3x squared plus x take 1 on the right hand side. Then rearrange however you like here to get all of the terms on the left hand side. So x squared take 3x squared, negative 2x squared, 4x take x, plus 3x, 4 plus 1, because that's a negative 1, so we need to add it to the left hand side, plus 5, equals 0. Here, I generally don't like the negatives, the first term to be a negative. I don't know why, it's just a personal preference, so I would divide through by negative 1. So this then becomes 2x squared take 3x take 5 equals 0. And then can we factorize this? So factors of 5 multiplied by factors of 2 to make 3. Well, the only factors of 5 are 5 and 1. And then if we multiply 1 by 2, we would get 5 and 2, which does make 3. So yes, we can factorize this. So the first terms have to be 2x and x. The next terms have to be 5 and 1, but just be careful how you're matching them up. Hello, Rules of Survival Walid, YouTube, welcome. So the 2 needs to match up with the 1, so the 1 goes at the end, and then the 5 matches up with the single x. And it's a negative 5 because we need a negative 3, so it needs to be negative 5 plus 2x. And then if we expand that out, 2x squared, excuse me, take 5 plus 2 will make negative 3, and then negative 5 times positive 1 makes negative 5. Then, therefore, we have x equal to plus 5 divided by 2, and x plus 1 equals 0, so this will be negative 1. So there are our two values of x, 5 and 2, and negative 1. And that was a 4-mark question there. Yeah, you could have done that, Yudoi. So up here you could have just done 3x squared take x squared, so I don't know. I've gotten the habit of doing that because sometimes when I'm teaching, people get confused when I flip the equation around, right? So I want to write the equation on the left-hand side. So I would have done it that way, but then it involves bringing everything on the right-hand side to the left-hand side. Sometimes that loses people for whatever reason, you know, so sometimes it's easier to stick with one side. Exactly, I completely agree, Yudoi. Okay, so That was question 18 of this paper, paper 1. Now, I think I might just do one more. Kind of losing my voice a little bit. Alright, I'll leave it up to you. So, next one. Either 21, sketch the graph for quadratic. Sketch the graph of a quadratic, or kind of a circle theorem-y type of question. Not really a circle theorem, but you know, show two triangles are congruent. Question 21 or 22. Yadoi says the last question. Okay, I'm leaning towards the last question then. I think you win the vote. It's 1-0. $21 is easy. That's good. 22. Alright. Question 22. Actually, this whole paper generally was not too challenging in my opinion and from what I've heard. But 2 and 3 I think were slightly more difficult. Alright. Question 22. A, B, C, and D are 4 points on a circle. AEC and DEB are straight lines. So they're those ones through here. Triangle AD is an equilateral triangle. So AED, equilateral triangle, all sides the same, all angles the same. Prove that triangle ABC is congruent to triangle DBC. So ABC, this one in here, DCB, this one over here. Alright, so where I would start with this would be to find, well, we know these angles in here, 60. Now, we can use the idea of angles in the same segment, or angles subtended by the same arc, they're two names for the same thing, to say that angle ACB in here, that's a terrible line, this angle in here, ACB, will equal ADB, which is 60. Okay, so these two angles are in the same segment. Similarly, for angle DBC, that's going to be the same as DAC. So these two angles here will be 60. And which means this triangle as well is also an equilateral triangle. Alright, so firstly that's where I'm going to start. So angle ADB equals angle ACB, and they equal 60 degrees, and that is angles in the same segment. Okay, hopefully everyone can see that. Then we've also said these are the same, so angle DAC equals angle DBC, and they equal 60 degrees as well, for the same reason. Okay, what next? Then might use a different color here. These two angles are also the same for the same reason. Now if these are 60 in here and these are equal, that means that whole angle must be the same. So angle DCB, it's hard to like kind of show which angle I'm talking about, but this one, maybe I'll use a highlighter actually. This angle in here must be the same as this angle in here. Okay, so firstly I'll state these are the same, so ACD and DBA. ACD can be confusing with all these letters and different lines everywhere. ABD. They are the same, again for the same reason. So we're using kind of the same theorem quite a lot here. Angle DEC equals 180 take 60. Yeah. Yes. Remember that we're looking for, let me kind of outline the triangles we're looking for here. ABC and DCB. They're these triangles in here. I'm trying to show they're congruent. So those two triangles there. So far, these yellow angles I've highlighted. Yeah, let me see if I can link that again. So all the papers should be here. It should be working. That link should work. Okay. So far, we've shown these two yellow angles are the same, which is a good start. The triangles also share this length here, BC. And we've also shown that these angles in here are the same as well. So it's kind of hard to picture, but if you can imagine these two triangles kind of separately, let me try to draw them quickly. We've shown these angles are the same. We've shown these angles are the same. And this side in the middle of those two angles is the same because it's shared. Yes, Blue Snow, yeah. Email me if you want those. I can send them to you. So firstly, I'll just state DCB and ABC are the same. So, oops, wrong color. So DCB equals angle ABC because well, we're adding on 60 to the same angles, so 60 plus ACD must equal 60 plus angle ABD, and we showed those two were the same. Okay, so those two must be equal, and therefore also we should state actually that BC is common to both the side BC. So therefore, a rule of congruent triangles is if you have two angles and the side between them is the same, then those two triangles are congruent. So that's what we have here. So therefore we can say triangle ABC equals triangle DCB because we have angle side angle. Okay. Not too bad. Not too bad. All right. Only for revision, William. Only for revision. Not if you have the same exams. Okay, I think that's about everything that I want to go through. If there's any other questions you wanted to have a look at, let me know. Other than that, I think yeah, I think that's just about everything. Thank you to those that left a like. I appreciate it. Feel free to leave a like, show your appreciation if you found this useful. Really appreciate it. What's your advice for me since I'm aiming for 8 to 9? Okay, so Blue Snow, are you in Year 11? I think you said that. Sorry if I'm forgetting. Yeah, I mean, I think what puts you ahead of everybody else is keeping to a schedule, keeping to a routine, and doing work in your own time outside of class. It makes a huge difference if you can come to class prepared or even ahead of what other people are working on. Your teachers love to see you taking the initiative. Like, I don't know if maths is your favorite subject or if it's just something you need to do, but regardless, to show initiative, to go to your teacher and you know, seek out questions that would challenge you and then ask for help. Teachers love that. If you go and kind of speak to them outside of lessons or whatever, and even you don't even have to do that. Just kind of make sure, as I said, keep to a routine. And it's interesting since I started YouTube to see the huge spike of people watching YouTube videos the night before the exam, like watching exam walkthroughs the night before, which, you know, maybe these people have already prepared and they're trying to get some last minute preparation in, but I don't know if you want to be in that position where you haven't done any revision and then the only thing you're doing is watching an exam walkthrough the day before the exam. That would be worrying. So yeah, I think I don't know if I can save this one because you know, I can go through it live. I think that's fine, but if I have it up on the channel, I think that's, you know, where it's kind of available for people to access. That's a different story. But yeah, Blue Snow, I'll just finish this thought. If you're just putting yourself ahead, you know, grades are essentially a competition, right? So if you're putting yourself ahead of everybody else, that's what gets you the 8 and the 9. It's kind of difficult to look at it that way, but yeah. I can, well, I will probably post my worked solutions in that folder that I shared. But yeah, I'm not sure about this video. Alright guys, thank you for tuning in. Hope that was helpful. And I'll see you next time. Bye for now.